Bismillahirrahmanirrahim. In the name of Allah, the most merciful and most beneficent. Last time we discussed about the data structure, what is data, how we organize the data, and what is data structuring in actual. I don't know why this screen is here. If there will be any distortion in the voice, please let me know. I don't know why this screen is here anyhow. So today we will discuss. Last time we have a discussion on arrays, list links, stacks, queues, and different types of that. Uh, so today we will discuss about arrays and searching algorithms and how we search the data, from the array in actual. So what is data structure in actual? We will recall it a bit more. Data structure is a way of sorting and organizing the data in your computers or in your machines so that you can use it after that effectively and efficiently. It can be very efficient if you will if you arrange the data accordingly if when you want to reuse it. There are different types of data structuring based on memory allocation, static or fixed size data structure, that is the arrays are the example of that one. And when you have linked list, it is the example of dynamic data structures. So based on representation, linear data will include in arrays and linked list, and non-linear in trees and graphics. Anyone has any idea why this window is here? Please let me know. It is not good, it's just distracting us. Okay. So what is algorithms and algorithm design? You know about that algorithms are the series of steps to solve a specific problem by with the help of mathematical or computational computer related problems. Algorithm design is a specific method to create a mathematical process to solve a specific problem with the series of steps. So what is an array? The collection of data elements in which all elements are the same, having same data type, for example, integer type, character type. So this is a array. Hence, homogeneous data like that has similar data types like 1, 2, 3, marks of the students, ages of the students, or this type of. Okay, we have example the marks of the student and names of the students. So an array of object oriented programming perspective elements or their references are stored at consecutive memory locations. Arrays is a static type of data structure as we already discussed it, and an array cannot grow or shrink. You should know that how many students you have in your class. Like you have for example, you have 20 students in the class, then you can generate an array. And if you don't know how many students it will be, so you cannot generate the array, as you cannot suppose you generate an array of 100 for 100 persons, however only 50 will come, then your the location, the memory of 50 will be, not good for us, or we just uh, lose it in actual. Similarly, if you just make an array of 50 persons and after that there will be 100, so you cannot shrink down or grow the array. Basic concept, you have the array name indexing from 0 to 9. Here we have an example, and the slots are numbered sequentially starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you have the data at the specific position. Like at position number 5 we have the data number 14. Suppose this is the marks of the students or any other type of data. So if there are n slots in the array, and the array, as you know, index is starting from 0, then the total number of the array will be n minus 1. Like here what is the n is 9. So array length should be is equal to 10. So if there are n slots in the array, the index will be 0 through n minus 1. Array size should is equal to n into size of the element, that is depends what is be there. So direct access to the element, if you know, if the array is in small in number, like here we have only 10 slots, so you can easily can get the data. Suppose if you want to know that what is what figure is on four slot, it is 0. However, because it's only 10 elements here, and if there is 1000, 10,000, 50,000, 1 lakh, 100,000, 200,000, then it will be very hard for you to get the data specifically. So sorting the data, sorted array is also important. Like sorted array is an array where each element is sorted numerically, like from lower value to the upper value, or alphabetically, that a b c to z. Suppose the name in the suppose we have 20 students in the class, and we just want to sort it down. So the name starts with A, like Ali, Arslan, Ahmad, so it will be in one slot. Then we have B, Basit, Bilal, then with C, D, E, F, and then so on at the last with Z, with Zubair or Zia. So similarly, if we have the students, we just want to add the data with ages, like the younger one will be the first one. So that is sorted type of array. Like here we have an example, and this window is just disturbing our example. 1234.02.3.4. Which window is here in actually? Give me a minute. I hope now it's okay. I hope so. Thank you. Okay, sorry. So we were discussing about sorted array. So here we have an example that 1, 2, 3, 4, like point 0.2 was the least one on the first slot, then 0.3, 1, and 1.5. Then we have unsorted arrays. In unsorted arrays, as we discussed in sorted arrays, we have everything in sequence and alphabetically. However, in unsorted array, it's not like that. It is opposite to sorted array. Like here we have 1, 2, 3, 4, and 1.5 came before 1. However, if it will be a sorted array, then 1 will come here and 1.5 will be on that direction. So what is homogeneity? All elements in the array must have the same data type, is known as homogeneity. Like in first example, we only have numerics 5, 10, 15, something like that. Here we also have a specific integer type number of data, like 5, 5.5, 10.2, 18.5. However, this is not a homogeneity here. If you can say on 0 slot we have a character alphabetically, then we have 10, no, then we have a number, then we have x, then we have 60.5. So this is not a homogeneity data, homogeneity data. Like you can say, if you will add the ages of the student, it's a homogeneity. If you will add the age and then the height, not age and then the name and the father name and then percentage, so that there will be no homogeneity in that one. So contiguous memory array elements are sorted at continuous memory location. You can see in this example that 0 with 5, and then alphabetically we are increasing the number till 9. However, in we don't need to be make it empty in any position. Like in this example, we just make it empty the 33 slot, and we just keep the number 30. Similarly with the 5, with the 50. So it's not allowed. You have to fill all the array. If there will be some gaps in the array, then you cannot search out effectively, and there will be problems you have to face for that. So using array, first you have to write the array name, and then in scare brackets you have to write the index. For in Java, for example, if you are using the Java language, then you have to use this script for the specific array. And if you want to replace the like in this example, data at 3 number slot, in first we have 3 number slot at -3. However, we replace 99 with the -3, like here in this one. So some more concepts in data, like minus one will always illegal. You know why minus one is always illegal? Because the array is starting from zero, so we don't have any minus one. Always array index will start from zero, and minus one is not there. So data 10 illegal if the you cannot write anything. You cannot use the numbers above the upper limit, like if you have 10 students in the class, how you can call the student number, student having roll number 11 or 12. Similarly, if the array has only 9 here, the last index number is 9, you cannot call the 10th one because we don't have it. And we also cannot use 1.5, 2.5, as we don't have 1.5, we have 1 2 3 4 5. So data 0 always okay because we have index number 0. Similarly, with data 9 is also okay because we have the last upper limit as 9. Array dimensionality. One dimensional array and two dimensional array we already discussed in our last lectures. So in one dimensional array it will be in linear, like we have an example here, 5 10 18, this one. Only one subscript is required to access an individual element. However, in two dimensional array we just make generate a table that has rows and columns. uh, for example, 2 into 4 matrix. So it 2 mean the second row, this one 0, row number 1, row number 2, and then matrix column number 4. So it is here the column number 4 is miss, 1 2 3 4, this one. So it's in this one, according to this one, 90 is the answer. So similarly we can calculate or we can hunt out the data. So this is two dimensional array in which we have matrices or tables with having rows and columns. So two-dimensional array, let the name of two-dimensional array is m. Suppose if the array, this two-dimensional array has the name m. So how we can calculate it? First element is at row 0 and column 0. So you can denote it like this one, m00 or m0 in parentheses 0 or 0, or m with the square bracket, two different square brackets with 0. More common, this one we usually use. So what will be the M12? So first one is the row and the second one is the column. So if we can say this one is these are two rows, here we have two rows and columns. So if we want to know 1 2, so first row and second one column, this one 25. So the number one in number will be 25 by this one. And what will be 3 4, you have to calculate and let me know. Thank you. So after that we have array operations, indexing, inspect or update an element using its index. Performance is very fast. Random number, if you just take a random number like 5, then you can get it. However, if your array is of, as we already discussed, 1000 or 10,000 or 100,000 elements, then it will be very hard for you to grab it. So in with insertion you can easily insert if it is on the first slot or on the last slot. However, if it is inside the array, then you will be it will take time. For example, we have an array here, and here is only you can say 10 indexes. If it will be, just imagine if it is 100,000 and you want to add a data at the position of 50,000, then the other 50,000 has to shift the data. You just insert one more, now it is 100,001 at the position of 50,000, and now you know that every just it will shift every number. Like at suppose if we consider it like we are going to add a data at position number 1, and we have 9 8 or more positions, so every position will shift it down. It will take time. However, it is only 10 indexes, so it will take maybe 10 second or 5 second. When you have 100,000 or 200,000 or 10,000 and you are just adding the data, so it will take much time. Similarly with the removal, in the removal, if you will remove then you have to shift it again. If you remove a specific content, then it will shift up. Like similarly we shift down with in the case of insertion. So array operation search performance depends on the algorithm. If your algorithm is linear, it will be slow, and if it's binary, then it will be good. So we will discuss in this lecture in detail the linear and binary. You will, I hope you will enjoy this one because it's very interesting searching algorithm of binary and linear one. Arrays in Java, when the array is created, memory is reserved for its content. Like a specific memory location will be reserved for that specific position. Like in the array, we discussed that the position number 3 we have the value -3. In actual, that location is specifically specified for that number. Initializing list can be used to specify the initial value of an array, in which case the new operator is not used. Like integer type we have, and then we have only three values here. The array is of three integer types. To find the length of an array, just use dot length, and you will know the how long the array is. Suppose in the first example we have only 10 indexes, then there will be a 10 as a result. However, when the array is of 1,000, 10,000, 100,000, then it will be like that. So you can check the length of array by a query dot length. Integer number grades is equal to grade dot length. So this is another format. What is searching? So the after discussing array, we are on search, how we can search the data from the arrays. Searching is a process to hunt out any item you place in your computer or in your machine at the specific location. The item may be sorted as records in the database, simple data elements in arrays, text in files, nodes in trees, vertices and edges in graphs, or maybe elements in other search places. The definition of search is the process of looking for something or someone. You know what is the meaning of searching. An example of searching is a quest to find a missing person. So why we need to do search? Searching is one of the core computer science algorithm. We know that today's computer stores lot of information, lot of data. A very common example of Nadra or any other, or like your own systems of your university system. If you just go to the IT section and just tell your registration number or your roll number or your specific code number, then the person just enter your name or your specific information and will get your whole information. In actual, there are 10,000 or maybe 20,000 students in the university, and if he is going if you just go back 100 years back, and there are registers, and every register has 10,000 20,000 data of 20,000 students, so it will take much time. So in computers there is lot of data, and you have to search it, and first you have to organize it sequentially and efficiently, so you can search it when you need it. So we will discuss the two main searching types, that are linear search and binary search. So array motivation we have here: you want to store five numbers in a computer, then you have to define five different variables. And if you have to store 100 or 1,000 or 10,000, then you will be in big problem because you have to add that. So you just need much programming efforts to make or to find some better solution for that one. Searching algorithm search for a target or a specific space. You should be very clear about that, how linear search works and how binary search works. Here we have an example that all students in the class and all numbers is given in list. One of the two possible outcomes, that first you will get the target, or the other one is you cannot get the target. Suppose in your class there is a student named Ali, so you can find him, so that is the success. However, your class don't have a student Noman, and the person came in your class and asked about the Noman, and in 20 students there is no Noman, and all the students are present from your class. However, there is no enrollment of Noman named student in your class, so that's known as the failure, or the target is not found. So here we have searching algorithm. Here we have an index of array of five numbers: 0, 1, 2, 3, 4, 5. We have number 20, 40, 10, 30, and 60. So target is 30 if we want to find 30. So we will find success or failure. Here we have 30, and we want to find target 45. So we will find success or failure. We will find failure because in this array there is no 45. We can find 30, but we cannot find 45 because we don't have this value. Similarly, we just discuss an example from our classroom. So list size is 5. As you know, n is equal to 5, 0, 1, 2, 3, 4, 5. And minimum index we have 0 and maximum index we have 4, that is n minus 5. N is total number and then minus 5 is the maximum number 4. And how you can get the total number? By the query dot length, and you will get the total number of the array. Then we have sequential search in a sequential order that terminate the condition and target is found as success or failure. If there is suppose 100,000 you can say elements or data in that array 100,000, and then you have to find, and then you will be fail. So it will be exhaustive for you and the machine also. So sequential search, we have the same index 20, 40, 10, 30, 60, that the minimum index is 0 and the maximum index is 4. How we can get that? With the help of n minus 5. And if you don't know about the total number of the array, total length of the array, then you can use the query dot length. So target is 30. Compare 30 with the value at index 0. Index 0, we don't have this value. Index 1, we don't have. Index 2, we don't have. However, at index 3, we have the values 30 and we just get the success here. Similarly, with the case of 45, we just check at 0, 1, 2, 3, 4. All the indexes we checked, however, we did not find the target 44, 45, sorry. And then we just are failure in this one. So here we have only 5 number in this index, so it's easy to find one by one. However, just imagine if there is 100,000 or 200,000 and 10,100,000 that indexes, then if you are going to check it one by one, it will be very exhaustive for you. Sequential search algorithm, a list of n elements and the target index from 0. Repeat step number 3 to 5, 3, 4, 5. As we just already discussed that, compare target with the list. If target is in the list, then return with the success. And if target is not in the list, then we will be failure. And how long you have to check it? N minus 1. And you know n minus 1 is the last limit. So you have to check till the last number. So now we have that is in actual this is a linear search. So we are just searching one by one, one by one, one by one, so it will take much time. So now we jump on binary search. You will enjoy this one, and I think you will prefer this one to save the time. Search through a sorted list of items. Sorted list is a precondition of for binary search. If there is no sorted array, like we already we discussed previously, that we have sorted array and unsorted array. In sorted array, we have every all the data in sorted way, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 50, 100, anyway. So in unsorted array, we just have 1, 0, 9, 5, 7, 14, 80, 4, 9. So this is unsorted array. So if you want to perform the binary search, then the data should be in you can say in a sorted array. Repeatedly divides the search space into two. Divide and conquer approach we will apply to give to take the success in this in binary search and save our time. So we have to apply the divide and conquer approach. So here we have an example with the binary search. Here we have an index of 10 numbers 0 to 9, so it is in total in 10, 5, 10, 18, 30, and so on. So we just want to find target key number 30. So here we have target key number 30 at 3 slot, 3 index position. First of all, we will what we will do, we will take the lower limit, that is 0, and we will take the upper limit, that is 9, and we will divide both, we will plus both and divide with 2. 9 plus 0 is 9, divided by 2 it is almost 4. So here we have 4.5, or you can say 4 for comparable. So here you will be at the mid position. So here you have 1, 2, 3, 4 at this position, 1, 2, 3, 4, 5 at this position, and you are here. Value at index 4 is 45 with the key, and but however you are going to find 30. So you did not find the position here. So 30 is less than 45, so you will ignore the remaining whole array. and you just will find here. So with this one operation, 50% of your array will remove down. If suppose you are going to find a value and there are 100,000 positions, and you just calculate it with this and you find that upper 50,000 or lower 50,000, just remove. In linear search, you have to check it one by one, 100,000. But in binary search, with the first operation, you just remove the 50% array. So your 50% time just reduced down. Now you have to find from the other 50%. Like in this case, now we will not going to check this side of the array from 4 to 9. So we will just check this one. Okay, now similarly we just skip this one. Now we have this array to check. Similarly, the lower limit is 0, the upper limit is 3, and we just check 0 plus 3 divided by 2, we have 1. At one position we just check it, the value is 10. So now we want 30 in actual, so position 1 has 10 value. So we will skip the below all the values. So we have one below value, we also skip it, and we also skip it because we already check it. Now we have only two values to check. Yes, now we have only two values to check. So lower limit is 2 and upper limit is 3. 3 plus 2, 2 plus 3 is 5. 5 divided by 2, and we find the index number 2. At index number 2 we have 18. So after that skipping we only have 1, and we will find that as a 30. So that is easy. So in three operations we just in four operation we just find the 30 position. And if it will be a linear search, so we have to check the 10 position. However, in binary search we just check three positions and we get the result. So just divide and conquer. When you will divide it, and you will know that where your array is, if you have an idea, and you will skip the other array totally. Now, similarly, we are just going to find 45. As in linear array, we just find the 45 with the 5, and we found it as a failure. And what we will do? Similarly, the lower limit and the upper limit, and now we just find it 40. No, not 45. We are going to find 40. So lower limit is 0, upper limit is 9. 0 plus 9 divided by 2, we are at the fourth position, that is this slot. And now we again just skip this whole array, and we have to find our 40 value number 40 here at this position. So here we just skip all. Now we are just going again on the binary search. Lower limit 0, upper limit 3. 0 plus 3, 3 divided by 2 is equal to 1. On one slot we have 10 number, and we need, sorry, we need 40. So these two also skip down. We have 2 again. We on the same position. 2 plus 3, 5 divided by 2, and we are at the position number 2. At position number 2, we index number 2, we have 18, and we need 40. So again skip it. In last we have only 30, only 3. Lower limit is 3, upper limit is 3. 3 plus 3, 6 divided by 2, 3. Then at 3 position we have 30, we don't have 40. So in these three operations we know that there is no 40 in the whole array of 10. So we are on the failure situation. However, if we just do it with the linear search, then we have to check all the 10 indexes, and then we have can say that 40 is not there. However, in binary search we just do it in 3 or 4 operations. So binary searching algorithm is informal. In the middle, lower limit, lower index plus higher index divided by 2, one of the three possibilities. Key is equal to the list, that is in the middle. Success and stop. Key is less than the limit. So this is all, we just do it, we just explain it in the words here. So linear search is a sequential search which uses a loop to step through an array, starting with the first element, as we already discussed. It compares each element with the value being searched for, and stops when either the value is found or end of the array is uncounted, as we perform all these in our study. So if the value being searched is not in the array, the algorithm will unsuccessfully search to the end of the array. So in linear search, the array elements are sorted in linear order. Searching the elements in the linear order make it easy and efficient. The search may be successful or unsuccessful, as we saw in the case of 30 and 45. Advantages of linear search: if you are going to say the first number, it's very easy. If you want to know the roll number one, the name of the roll number one in from your class, it's very easy. However, if your class has 100 students and you want to know the name of 99th number student and you have to check from 1 to 99, it will take much time. So if you are lucky if you just want to check the first index. However, if you want to check the last index, then you are not lucky, you have to check the whole directory. So every approach has their own positive and negative points. The linear search is simple, it is very easy to understand and implement. It does not require the data in the array to be stored in any particular order, so it does not depends on number or elements in the directory. However, the disadvantages we already discussed, that if there is a 100,000 or 10,000 or 100,000 indexes, then it is will be very hard for you to check one by one all, and your search time is proportional to the number of elements in the directory. If there are 10 indexes, it will take maybe 1 minute, and if there is 100,000, then it will take much time. If it has very poor efficiency because it takes lots of comparisons to find a particular card in a big file. The performance of the algorithm scales linearly with the size of the input. Linear search is slower than other searching algorithms because it has to check all the indexes one by one. So analysis of a linear search: how long will our search take? It depends on the number of the elements in the directory. The target value is the first element of the array, so the search takes some tiny and constant amount of time. However, in the worst case, if you want to find the index number 99 from the 100 of the from the directory of 100, then it will take much time, as the amount of time is proportional to the length of the array. The longer the array is, the more time it will take. That our target value is somewhere in the array. So we already discussed that. You just have to read it, as we have very short time to finish this lecture. Similarly, with the binary search, the general term of for a smart search through sorted data is a binary search. The initial search region in is the whole array. Look at the data value in the middle of the search as we perform it, and we just skip the whole array forward. If you found the target, then you have to stop it in 2 or 3 operations, otherwise you have to perform the operations, and you just skip the array that is not in use for you, or half section of that specific array. If your target is greater than the middle data value, the new search region is the higher half of the data. So you can continue the steps, and you have to perform the steps again and again, and you have to skip the region that is not related to your target or query. I hope you understand the concept of arrays and how we implement and how we search data from array. So linear searching and binary searching, and why we do the searching analysis. Thank you so much everyone for joining. If you have any question, you can raise your hand. Thank you so much everyone for joining.